Hello, welcome to PC Drills, where you find help on how to handle your PC related issues. Today we are going to be continuing with lesson 3 of our algorithm and programming languages chapter. For lesson 3 we'll be talking about the flowchart concept. To begin, our objectives will be just an introduction, some flowchart symbols and uses of each of those symbols. So what is a flowchart? A flowchart can be explained or considered as representing an algorithm using shapes and symbols. When we say shapes and symbols here for a flowchart, we have specific shapes that you can use for translating an algorithm into a flowchart. So a flowchart is simply you representing an algorithm, but you are using shapes or symbols. For the shapes and symbols, you can have something like a circle, you can have a rectangle, you can have a parallelogram, and you can also have this diamond shape. Each of these shapes have a particular option that it represents. So if you are using a circle, you cannot use a circle to represent what a rectangle is being used to represent. If you are using a rectangle, you cannot use it to represent what a parallelogram is used to represent. So with a flowchart, you need to know where to use a particular symbol, where to use your circle, where to use your rectangle, where to use your parallelogram, and where to use the diamond shape. There are other symbols, but these are the most commonly used ones. For flowchart symbols, some standard symbols which are frequently required for flowcharting algorithms and programs include the following. We have terminator, a process, a decision, data, we have connector, and we have arrows. Each of these is being represented by a particular shape. So you cannot use the shape of a terminator to represent a decision. And you cannot also do that for any other one. So if you are using a decision, you use a shape that represents decisions. If you're using data, use the one of data. If you're using process, use the one of the process. That's basically what a flowchart does. Just represent a flowchart using shapes, and the flowchart will be able to execute given that it resembles what you gave the particular program as an algorithm. So let's begin with a terminator. A terminator is an oval shape which indicates the start or the end of a process, usually containing the word start or end. So if you write your algorithm, usually at the top, the first one that you start with is a start. It looks like a circle, but you cannot really say it's a circle. It looks like more of an oval shape, like an egg. It is longer for the part for you to write start in the middle, but all around it is a little bit like an egg. We have the circle symbol, so that's why you need to draw this one different from the other one. This one is different from the other one. The other one is just a small circle that we also use to represent its own particular function. But this one of a terminator is either having a start or you're having an end inside. Sometimes you see both begin, you see end, and see start, stop, begin, stop, stop, start, and so on. But the thing is, to use the terminator, you must have these particular words. You can remember and use start and end. Start for the beginning, the first one that you see, end for the last line, the last particular shape you draw will be this shape, and you put end inside of it. Next, we have a process. When we say a process, it simply means performing a particular calculation or executing a particular instruction. So when we say a process, processes are usually represented by rectangular flowchart shapes. So when you see a rectangle in a flowchart, this is what you will see. It is to represent a particular process. For example, they say x is equal to y plus a. It can be written as, you draw your rectangle. Inside the rectangle, you put x equal y plus a. Just having this shape, you know that it is a process. And having this particular one inside the rectangle, we know that that is the particular process we are representing at that particular step. Next, we have the decision. A decision is usually a diamond flowchart shape. When we say if a is greater than b, if y is less than 5, if any question that can be answered with a yes or no question, you can use this particular decision symbol, which is the diamond. You say diamond is simply what you need to draw. I've colored everything here in black for you to be able to see it visually. When you just see the part that you see in black, which look like a shape, is what we are talking about. But if you are drawing in your program, you don't need to paint it, you don't need to draw and color. Just draw your diamond. It looks like a rectangle that has been rotated, something like that, and you just continue. So usually with this decision, you can have maybe if x equal to 2, and then you have the part for the x and for the yes and no value. You can say if yes, continue with the yes part here, and the no part maybe below. If it does not correspond to the yes part, it definitely goes to the no part. So if you have a value x, and you're checking if that value of x is less than 0 or is greater than 0, it is either it is less than or it is not. So you cannot have the same value that has 3 possibilities. It cannot be less than and greater than at the same time. You cannot see a value that's less than 5. At the same time, that same value is still greater than 5. So in programming, when you check your conditions, is either one is correct and the other one is wrong, or the next one is instead the one that is correct and the previous one is wrong. So you just need to know if value is not greater than 5 and it's a number, then it is less than 5. If it is not less than 5 and it is a number, it means it is greater than 5. The part of equal to is another one. It's a little bit different, but it's also a condition. You can say that is this number equal to 5? It's either is yes or no. If it's not equal to 5, then it's a different number. If it's equal to 5, it cannot still be a different number. So in programming, it tries to eliminate all these possibilities, so that if you know that it is 1 that we have here, you cannot confuse again between 1 and 2. So just get the idea into your head. It might be confusing, but just get the idea. When we start doing examples, you start to understand much better. Here we have the data symbol. The data, we say it is a parallelogram flowchart shape which indicates data input or output for a process. So if you have to display maybe a username, or maybe get X from a user, like last time on the first lesson that we did, I was doing a simple Python program. I say input your name. All of those ones that are telling the user input something, you are dealing with this data. The other formula, if you remember, if you recall, there was a formula that had an error. When you find the average, it does not calculate it correctly. That is where you use the other previous one that we just passed, the one of the process. But now for the data, it is when you are communicating with the user. Either you are getting something from the user, printing to the user, or displaying to the user. Printing and displaying basically mean the same thing. Getting means that the user will provide you something. Printing means you show something to the user. To do both the printing and getting, you must use this particular symbol. It looks like a rectangle that has been twisted. We call this parallelogram. Next, we have the connector. It is a circular flowchart shape used to indicate a jump in the process flow. They are also used to link two or more arrows. They are also used to link two or more arrows. The other time I told you earlier in the beginning, you should use the oval shape. You should use something like this, the oval shape, because there is another one that resembles a circle. Actually, this one that we call connector here is a circle. This is a circle. It's just that with this one, we don't write anything inside of it. So it's usually very small in size. That's why I've put it here very small. I did not just draw one big circle. So you should know that there's a difference between the one that is like an egg, like this for start and stop, and there's another one that's just a small circle that just shows that two things are linking up somewhere. So if you are to join maybe two arrows, maybe after leaving the right side and another one to leave maybe from the left side, if they meet somewhere, you link them with this dot and you continue. And basically with flowcharts, they execute from top to bottom, and any other directions must be shown with these arrows. Even from top to bottom, you will also have these arrows generally that have been drawn for you to know which particular side you are using. But you can also have sometimes that some things will need to be executed from bottom to top. The arrows still do the same thing, showing the direction. And for the arrows, you can have them pointing in various directions. The arrows are simply to show a flow control in the process or program. And it shows, you can see it shows which order to follow. The arrow can point downwards, point to the right, point upward, point to the left, in any direction, almost any direction. You can have an arrow. Well, for this particular lesson, lesson 3, the flowchart concept, this is all we gathered. But we are going to continue with the work on the next lessons. We hope it was useful to you and you really learned something from the course. And if you are down to something or you have an issue, you can leave it in the comment section or send it to us through our email, contacting us through any of our social media, or just searching online for PC drills. Wherever you find this logo, you get to us. Or you just put hashtag PC drills, or you just search for this handle your computer issues with ease. Luckily and hopefully you will get to us through one means or the other. See you next time on our next video. Thanks for watching. Please like, subscribe and share if you find it useful. If you don't find it useful, we are sorry for everything. Bye for now. See you next time.